So we're going to learn two theorems today. One is called the mean value theorem. And hopefully you're like, I already learned the mean value theorem from last semester. So MVT, yes, but this is the mean value theorem for integral. So it's going to be a little bit different. So this is the first thing we're going to learn. Mean value theorem for integrals. So yeah, okay. So it says if f is continuous on the closed interval AB. If it's continuous on the closed interval AB, notice that it does not have to be differentiable. It just needs to be continuous on the closed interval. Then there exists a number C. Do you want this? In the closed interval AB. Okay, so there is a C number that's between A and B such that the integral of f of x dx from A to B is equal to f of c times b minus a. Okay, mean value theorem. If f is continuous on the closed interval a to b, then there exists a number c in the closed interval a to b. So there is this number c that's between a to b, so that the integral from a to b of f of x, remember that means the area under f of x from a to b, so that area is equal to f of c times b minus a, which I will talk about what that actually means. Okay, so make sure it's copied down first, and then I'll show you. So let's just draw our typical graph again. F of x from a to b. So if we're trying to find the integral, then we're trying to find this area. Okay, so let me just write that. That's from integral from a to b of f of x dx. They're saying that if this function is continuous, meaning there's no break, and it's in a closed interval, which means you have a definite a and definite b, you just want to find that area. This area must equal f of c times b minus a. What does that actually mean? Let's draw that graph again. So this is the graph. They're saying that between a and b, there must be this number c, some number c. Let's just say here. So that f of c means here, right? This is f of c, the height of c, times b minus a. So it's going to be the height times the length. If you have an area like this, there must be somewhere on your graph so that you have the same exact area. Yes?
Is that because it's an intermediate value theorem and then there's like that height where it's in the middle of the app?
I don't know about intermediate values theorem. Maybe. Let me think about it more.
Below and under cancel each other out, huh?
Kind of. So basically, you have this area, some area. You must have another point on there that has that same number when you find the area as a rectangle.
I'm just saying there's a rectangle that has the exact same area as the...
Yes, there is a rectangle that has the exact same area as the integral.
Okay.
Oh.
And yes, there is another, yes, thank you, Taya. So there is a rectangle that has the exact same area as that integral. And that is somewhere that you have to find. Are you guys okay, or you need me to show you a number proof? Yes?
So, is the integral usually like a finishing number, or is it ever like repeating?
That's a great question. So we're just talking about definite integral now. So there is just a number because you're always stuck between two bounds. But there are indefinite integrals where it's just a function, like this.
Okay.
Yeah.
So to find c, would we just find the integral and like divide D1
Yes. Are you guys okay, or you need another proof with some kind of very easy function to show you?
Just do the
No.
proof just in case.
Okay. No.
Okay, let's just do a really quick one. So let's say f of x is just x, and we are trying to find the area between 0 to 5. Okay, easy one. So x between 0 to 5. So that's this one. There must be another place in here where we have exactly the same area. It must be like this, right?
Yeah.
So the area, this is a easy, so the triangle area is going to be 1/2 base times height. So that is 12.5. There must be another place where you have the same width, right? So this width is 5 times some height. You must have 12.5 as well. The height is 2.5. So at 2.5, you have the same height as the integral.
And then when you just make that like equal to the f of x to find what that is.
Yes,
Okay.
correct. And then you make that equal to f of x, which tells you what that c value is.
Got it. Okay.
Why do we need to see them?
Hold on.
What is the point of finding the area of the rectangle such as that?
Yeah, that's Taya's question. So there is we'll look at applications soon, but let's practice finding c. Okay, find the value of c guaranteed by the mean value theorem for the function over the given integral. For integrals. Okay, so so the area between 0 to 3 of the function x cubed dx. So whatever that area is, must equal somewhere on this graph. So somewhere on this graph, we don't know what that is, times the width of the base, 3. Okay, so in order to figure out what c is, we gotta evaluate that definite integral. So first, find the indefinite integral. What is the integral of x cubed? Okay, x to the 4th over 4. Evaluate it from 0 to 3. 81 over 4. Right, because the 0 doesn't matter. Okay, that's equal to 3 times the function of c. Function of c, the function is what? X cubed. So this is really c cubed. Right, f of c means put c in as x. Okay, so now we just have to find c. So we're going to divide by 3 first. 81 over 12, and then we're going to cube root. I don't know what that is. What did I say? I think I canceled this first. So 27 over 4. And then cube root 27 is 3. So 3 over cube root 4. Let's just leave it like that. And it's between 0 to 3, so that's the only number. So at c, that number, we have the same area, that rectangle will create the same area as the integral. Yes?
But if it was like a sine or cosine graph, there has to be 2 points.
We'll see, because when you solve the equation, you would be able to find the correct amount of x's that would create this same area.
You mean c's?
I'm sorry, c's, yes.
It depends on how long it is though, right?
Okay, so let's go ahead and try another one. The integral.
If you have 2 the same height.
The integral from 4 to 9, square root x dx is equal to f of c, whatever that number is, of the same base. The base is 9 minus 4, so that is 5. Okay, go ahead and figure out what c is. Okay, so c is equal to 38 over 15 squared.
Yeah.
Okay, next.
Okay.
Can I have you guys take out your calculator? We're gonna try one with the calculator. This is, you cannot integrate it by hand easily. And let's try to see how we're gonna find this with the calculator. So again, it's a mean value theorem for the integral. So where is this area equal to something else? Okay, so please make sure you still remember how to use the integral function on your calculator. So let's set it up first. Integral from 0 to 3 of 10 minus 2 to the x dx is equal to f of c. Oof, this is going to be a little crazy because you got to find x from 10 minus 2 to the x times 3 minus 0. Okay, so if you're stuck on finding x, please let me know. It's just after the calculus part, that's all algebra. So just, do you remember what to do a few years ago? You had to find x. To find x. Okay, so go ahead and find it, or if you're stuck, let me know. So solving this, you get c is equal to 1.751 about. So remember to round to the 3 digits after the decimal point. Okay, let's look at another theorem. This, yes, go ahead.
Yeah.
Yes, of course. Okay, so let's look at this question. So this part is the part you're going to use the calculator. So you use the calculator and it tells you it's 19.90113. I try to round as much as I can because I'm not at the final answer yet. That's equal to 10 minus 2 to the c. So that's the function with c times 3. So I'm going to divide by 3 first. I get 6.6337 equals 10 minus 2 to the c. Subtract 10, so negative 3.36629 is equal to minus 2 to the c. I'm going to divide everything by a negative, so that becomes positive. To get the c down from the exponent, you need to log both sides. You can use log, you can use natural log, whatever log you want, as long as you do the same on both sides. So then c comes down. C log 2 is equal to log this number. And the last thing you want to do is just divide by everything that's next to c. So c is equal to log 3.36629 divided by log 2. Yes?
Can you just, because there's you can change the base on your calculator.
Yes, if you can change the base, then yes. Since you have a calculator, just do that.
Yay. Okay, cool.
Okay.
But
All
we
right.
can just do that and plug it into our calculator, right?
Okay. Yes. All right, next. We have another theorem. This is very closely related to the mean value theorem. It's called the average value of a function on an interval. So it says if f is integrable on on a closed interval a to b, then the average value of f on the interval is 1 over b minus a integral a to b f of x dx. So if you have a function f that you can integrate from a to b, then the average value of f, so we're going to talk about what that means. Average value of f is that formula.
Is fx?
Okay. Question?
What would make it not integrable?
If it has discontinuity.
Any discontinuity.
It's jump or there's a hole.
Okay.
Yeah.
So even a hole?
Yeah, a hole is not integrable. If you do want to integrate, you have to split it.
Okay.
Yes.
Value, x value or y value?
Y value, because average value of f is y. Right. Okay, let's talk about what that means again. Okay, we have this function f of x. Average value of f. What does that actually mean? That means if you find every point. So usually when we talk about average, we're talking about discrete values. Discrete values means 1, 2, 3, 4, 5. They're not continuous values, right? Let's say you're trying to find your average, test grades. So you have 90, 95, 90. That's 3 numbers. So then you add them together, divide by how many there are, and then you have an average. Normal idea of average. But if this is a function, you have infinite amount of numbers. You cannot divide by discrete amount of numbers. Does that make sense?
Yeah.
Yeah. So then if you do want to find the numbers, you will have to find every single number, and then you ask yourself how many there are so you can divide. But that is impossible because you can have infinite amount. So you can't think of average the same way. So we're going to be a little bit smart. So this is kind of the proof part. Okay, so the average value. So let's think about average value and say, like, what if I can make it into discrete amount? Then I would actually say my first x plus the second x y value plus the third one, and so on. And then I keep adding until I added all of the y values, right? And then I divide it by the total amount. That would give me the average, right? Now, another way to say that is 1 over n, and then just the sum from first one to the nth one of all of my y values. Oops. Raise your hand if you have a question. Yes?
So we are looking for the average y.
We are looking for the average y, but we are going to try to get around not having discrete amount of numbers.
But you said, you said that then the average value of f.
Yes.
Isn't f x?
No, f is y.
Oh, okay.
Okay. Okay, so now what we want to do is look at this and say, what's another way to get around it? We're going to do this instead. We're going to multiply by b minus a over b minus a. That's okay because that's a 1, right? You can multiply any expression by a 1 and not change the expression. Next, we're going to take this part out, put this part in. So that's going to give me 1 over b minus a on the outside. And then I have the sum from I equals 1 to n of the function. And then I have b minus a over n, which is delta x. Right, b minus a over n is delta x. So this becomes 1 over b minus a of the sum of I equals 1 to n of f of c I delta x. And then we learned this, right? What is this? The integral.
Oh.
So this is 1 over b minus a of the integral from a to b of f of x dx. So we kind of got around of not knowing how many numbers there are, but we said that's just equal to that, and integral will be able to help me figure out the average value. Okay, another way to kind of think about it, graphically. Looking at that graph, where do you think the average y value is? You have a graph like this. Where do you think the average is? Middle, right? Middle, right? It has to be around the middle. So,
Is it C?
yes, it is just the mean value theorem. So if you kind of look at this number, right, and compare that to the mean value theorem. It's literally the same, right? You just divide by that, you will get the average value. Yes? So this is really just equal to f of c.
What?
Right? They're exactly the same thing.
So you.
All that works.
So you're just trying to find the same thing. Mean value theorem finds that x value, average value finds that value as c.
So C is the average.
Whoa.
Right? Average value is just that number. Mean value theorem finds that x value. They're the same.
That's cool.
Okay? Yes.
So the mean value theorem finds the number that is the average.
Yes, yes. Okay. We're ready. All right, so the only one thing that I need to tell you to be careful on is average value of what? It's the average value of what? F of x. F of x. This is where even I got really confused last year because we learned two averages. The first semester we learned the average what? The AROC means average rate of change. So people always get those two confused. Average rate of change and average value are not the same. Okay, so let's kind of talk about that. Average rate of change, the AROC, is, do you guys remember what it is? Okay, what is the formula? Not f of x. F prime.
Oh my.
Right? We're finding the derivative, right? Average rate of change. Well, okay, equals to what, though? The formula.
F x plus
F of
B.
B.
Minus f of a over b minus a.
Yes, okay. So that is the average rate of change. Average value of a function. This is f of c. Let's just call it f of c. 1 over b minus a of the integral from a to b of f of x dx. Okay, the big thing is, or the just if you want to just know the summary, average rate of change finds the derivative. This finds the f of x. They're not the same, right? One is derivative. One is just what is the average of that function. They're not the same, and I'm just giving you like a big warning. Every year, people will get this very confused. So please read the question very carefully. Do they want the average of this function, or do they want the average rate? Okay, rate and that value is not the same. Yes?
And then the f of x for average value, that's not like the big f of x, right? That's the antiderivative. There's so
What?
many f of x's. It's
Okay, let's just do a few examples. I think it might be more clear. Yes?
Keywords being rate and value.
Correct. Correct. Okay, so find an average value. Find an average value. So 1 over b minus a, the integral from a to b of f of x dx. I'm just writing that formula, and then we can plug everything in. 1 over 4 minus 1, integral from 1 to 4. 3x squared minus 2x dx. Okay, do this by hand. This is, the numbers are not very big, and the integral is very nice, so it should be pretty easy. Okay, the answer is 16. Okay, so, you know, the calculus part is the easy part, I guess.
Again.
The algebra part is just, you know, please be
I
careful.
think we should go back. Wait.
So we can multiply the area with 1 over 2.
Yes, yes, correct, correct. All right, let's try this one. This one's a little different. You have a piecewise. Find the average value on the closed interval. So to find the average value, it says it has to be integrable. But we can't integrate two functions. So we need to split them.
So do one.
Yes, you have to find the average value individually for each interval and then just add them together. So we can't do this all together in one shot. So we're going to have to do them separately. But let me just show you the formula again. 1 over b minus a, integral from a to b of f of x dx. Okay, we cannot integrate this as is because it's splitting at 3. So we need to do them separately, yeah. So 1 over 5, that's the length of b minus a. We're going to do 0 to 3 first. And then we're going to do 3 to 5.
Oh, so wait, we multiplied all by 1 over.
Yes, correct.
Oh.
Can you do it separately if you want
I don't think so, because then you're finding an average value of this and average value of this, and you can't really say that they both have 50-50 equal weight to this whole average. So, sorry, huh? 2 equal signs? You mean this part? No, I left out that part, so that's okay.
I'm sorry, I can't see.
Oh, okay, that's okay. Yes.
How do you find the antiderivative of square root of x plus 1?
Fraction form.
X plus 1 to the 1/2.
Chain rule.
Yeah, it's going to be a chain rule. So
Huh?
the
Antiderivative.
antiderivative is going to be x plus 1 to the 3/2 by guessing. Integrate that, you get 3/2 x plus 1 to the 1/2. If you do another chain rule, you're going to get 1, which is fine, right? Derivative of x plus 1, which is 1, so it doesn't really matter. So then we just don't want that 3/2, so multiply by 2/3.
Yeah.
Oof, okay, 4/3.
What?
Okay, so I think it's just a matter of being really careful. So I'm going to just skip it. If I will send you guys the answer by hand, but it's gonna take too long. Okay, let's do a calculator thing. Okay, this one's a little different. Okay, a particle moves along a horizontal line so that its acceleration is this. If the velocity is 2, if the velocity at 2 is 5, okay, v of 2 is 5. What is the velocity at 4?
No.
Okay, this one is, you can solve it your old way, but I'm going to show you how to do it really fast with FTC part 1. Okay, so we want to find v of 4. So we are given a. So we know that velocity is the integral of a. Okay. Now we're going to utilize FTC part 1. FTC part 1 says, if I have an integral of a of t dt, and let's look at the time that's given. We're given time at 2. We want to find time at 4. So let's say from 2 to 4. Okay, utilize FTC part 1. FTC part 1 says, if you integrate like that, what is it equal to?
The big F of A.
The big f of a. So what is the antiderivative of a? What is the derivative? Yes. So v of 4 minus v of 2, right? That's FTC part 1. What do we want to find? We want to find v of 4. What do we know? V of 2. So very easy. V of 4 is equal to the integral plus v of 2. This part, you're supposed to use a calculator. So it's a very, very easy question if you just use FTC part 1. If you didn't realize you can do it, you would have to find an indefinite integral, solve for c, and then plug in 4. It's going to give you the same answer. It's just much, much longer. Okay? So go ahead and try that. This is a very easy question. You got to realize you can use FTC part 1. All right, this answer is 65.989.